Good morning again. This is Bill Gens, Sales and Technical Director with TopSolid USA, coming live to you from Chicago. Yes, I've lost my mind. We are, what are we, 12? 14. Thanks, Joe. We're 14 webinars in for the week. I can't do math. There's been so many webinars. Anyway, while people are joining, I'll introduce the rest of the team again. We have Joe Hart, Technical Manager, Mike K, the Wonder Nut. It's been one of those mornings here at TopSolid. All right, let's get started. Mike K is technically the sales manager, but I think we're giving him a nickname today. All right, so this webinar, we're going to focus on some additional improvements in TopSolid, TopSolid Cam, excuse me. We're going to focus on link movements, tools and cutting conditions, and machines and components. So let's have a look. Maybe. There we go. All right, so let's start with some link movement improvements. So this first one is really a specific improvement for a specific type of machine called a index. So this machine up here on the upper turret is kind of unique in the fact that it has a milling head over here as well as a standard turret over here. Okay. And with that, you can obviously rotate this, okay, and index it and whatnot. But what you actually have is a tool holder that has multiple tools over here. But this is tool changeable over here. And what happened is on the link movements, it became difficult to manage what the correct tool change position was. So the improvement this year is to manage conditions like this better, so that it pays attention specifically to the tool holder and calls the correct tool change position. There's really not much to show you as much as it is to tell you that these machines are just supported better now. Alrighty. Next. So, in all virtual jog movements and link movements, the feed rates now display in the same unit as the one chosen in the cutting conditions panel. What do I mean? So, if I go to my roughing here, okay, and I go to my cutting conditions panel, you can see here we're in metric, right? Meters per minute, millimeters per rev, and so forth. And if we go into the link movement, where are we at right here? Millimeters per rev. So we had a little oversight on our side where it didn't pay attention to the units being called there, and sometimes there was a confusion in the custom feed rates here. So that's been improved upon as well. Moving right along. I suppose I could have done it right there, but I'm going to do it in this one anyway. We've also added within link movements, just go ahead and edit the approach. You now have the ability to add a delay, again, based on time or revolution count. So it's accessible right here. You can now add a dwell all you want within your link movements. And then finally, drag and drop link movements. So this one's actually kind of cool. So you have operations that you're doing, right? And maybe you want to edit the approach on this one. So let's go to our link movement here. And we want to use the same approach that we used on this toolpath. So you can literally just left click and hold, drag and drop it to here, and it copies all the same exact link movements from this one, switches you to manual, off you go. So again, just another example of TopSolid making things a little bit easier, a little bit more efficient for you. Cool. All right, that's it for link movements. Next, we're going to move on to cutting conditions. So, let me get to my notes here. All right. This one is just a minor one, but it's a nice one. So, if we look right now at our cutting conditions for pocketing, okay, that's down here. Our cutting speed is 166 meters per minute. We're at a .32 millimeter per tooth. If I go and create another tool path here, right? And it's using that same tool. It's now going to automatically use the same cutting conditions, okay? The only restriction to this, where it won't use the same cutting conditions, is if those cutting conditions are being supplied by an abacus or a method or a default parameter of some type, then of course it will calculate however those objects want the cutting conditions to be calculated. Otherwise, we just assume moving forward that if this tool has been used somewhere in this program and you're calling it again, that you want to use the previous cutting conditions. All right, next. So we have some new parameters available to you within a cutting conditions abacus document. So it's in the specific field here. First and foremost, now it is possible to specify your coolant pressure and to activate the tooth feed rate locked option, okay? As well, you now have the AP and AE parameters in these specific cutting conditions, okay? So AP being the depth of cut, AE being the radial depth of cut. So these cutting conditions can now be set specific for specific depths, okay? From there, here, open up our laser box as well because we'll show how this works. You also have another parameter in here. Did I go to the wrong one? That's the wrong one, sorry. This one. There we go. You also have another new parameter in here called quality, okay? And the idea behind quality is you can have up to 4 different cutting conditions for the same tool. So you have a roughing cutting condition, a semi-finishing, a finishing, and then just a general cutting condition, okay? So how does it work? When we go into our environment here, and we go here, and for example, we choose, so let's use contour roughing, why not? And if we go into our cutting conditions here, you have the cutting condition document being used, which is the 4 cutting conditions per tool document that I just showed you. And then in here, you're going to see all 4 of them. So I can say, let's apply the roughing cutting conditions. And you can see now we're set to roughing. Or let's do the pre-finishing, apply, now we're at our pre-finishing. So at the end of the day, you have the ability to have 4 different cutting conditions per tool now. Well, AE and AP auto-populate on the procedure is the question. So with the depth of cut, the radial and axial depth of cut, the way it works is that is the target axial depth of cut, target radial depth of cut, and the cutting condition will interpolate based on the depth of cut that you've chosen. Okay? So it's a starting point. Think of it as a baby abacus. Okay? Alrighty, let's keep going. Close all this stuff down. Alright, take into account the real AP. So, at the end of the day, this is, actually it's easier to show here this way. So, oh, I should mention, if you set AE and AP to 0, hold on, I have a note about this. Blah, blah, blah. Putting 0 in these parameters will ignore the parameters. So, if you enter 0 here, then it just uses the rest of your cutting conditions and it ignores the calculation done on those. And then on this next option, which is called using the real AP in the abacus, really what's important is this. So it used to be that the AP was calculated based on this right here. But if I set this to 10 millimeters, for example, and based on the depth of cut, my real, zoom up on it, my real AP value is this. And so now the cutting conditions will actually look at this value here, the actual depth of cut, to calculate the cutting condition for you. Okay. Now, keep it going. This one I think is kind of interesting. This is a new option that was added to our cutting conditions. We now have cutting conditions groups, okay? And the groups are to allow you to assign similar cutting conditions, or the same cutting conditions, I should say, to a specific group of tools. So you start by creating a group, okay? So we'll call this TopSolid USA. Now that we have TopSolid USA, I can come in here and I can go find whatever tools I want to add to it. I can add, let's say, I want to find something useful. Here we go. We'll add this one, and we'll add this one. Okay. And now that I have those added to my TopSolid USA group, I can come over here and I can set exactly metric or imperial, whatever. I want this to be 5,000 RPM. I want this to be 750 millimeters per minute. I want this to be jet coolant. I want my AE to be 3 and my axial depth of cut to be 5. I'll say, oops, I'm in inches. That's weird. Millimeters. All right. Now, we set these groups. So how do they work? Then when we go into the actual document, okay, and let's say we go to our drilling here, you have the cutting conditions per group, and it's just pulling it directly out of that. So this is for drill 6 to 8. That was the name of it. And it's going to use the identical cutting conditions for those tools. Okay? So it's a way to simplify and speed up the creation of your cutting conditions. Alrighty. Let's keep going. All right, so this next one is pretty interesting. You can now set cutting conditions down to the right place here. Yes. You can set cutting conditions, and let's call it a local cutting conditions, directly from the tool manager. So for example, make sure I didn't save it this way. I didn't. Perfect. If I go to my equipment tab and go to my tool manager, I can go to my twist drill. I can right click and go to specific cutting conditions. Now when I do this, this dialog box will appear and I can type in what I want. I want this to be 5,000 RPM. I want this to be 300 millimeters per minute. I want this to be mist, okay? And whatever. Now, if I hit apply here, it's going to apply that cutting condition everywhere that tool is used in this document, okay? I can also just green check it. Either way, when you green check it, it creates a new folder in your entities manager called cutting conditions, and it's twist drill diameter 6. It's just the name of the tool, okay? To apply that cutting condition, then we go into our drilling, go to your cutting conditions, and we search for the name of the cam file. In this case, it's milling-set cc APAE tool manager, and now there's your cutting condition. Okay, so again, there's a couple of different ways to work with cutting conditions in TopSolid. We're just trying to give you a multitude of ways to do things. Why would you have local cutting conditions? Maybe you want local cutting conditions in a specific template for a specific type of work where it's only going to affect this one customer or this one job. So why build dedicated advocates for all of that? Okay, perfect. Let's keep on going. Alrighty, so this next one is a wonderful one. It is now possible in an abacus to output or select surface footage calculations for turning tools, drills. Hold on, there's 3 of them, drilling, threading, and turning. Okay, so now you can actually create cutting conditions for those types of tools to be used inside of TopSolid. Okay. And finally, this one, I'm going to give you the end result of it. Okay. But we have a new document type called Customize Coolants and Pressures. Okay. And the whole idea here is to give us and you better control over different types of coolants. Okay. I'm going to show you this kind of at the end position here. Some of you guys have machines that the cutting conditions, especially for coolants, can get quite detailed. Okay, especially if you can control pressure, and the pressure has different options and what have you. So now, what the cutting conditions, or pardon me, what the coolant document does is based on the type of coolant you choose, this will automatically build additional entries for you in the dialog box. These entries then will be mapped into the post processor. Okay? These entries, depending on what it is, it could be a drop-down menu full of options. Just depends on what it is you're trying to do. Okay? You can have them called whatever you want. You can name them whatever you want. This way you can match up precisely to the way your machines work. Now, this document is open to users. However, it does require that it is hooked up properly in your post processor. So if you have the types of machines that have a bunch of crazy coolant options with a bunch of sub control options, you need to reach out to us so that we can discuss with you how to get those implemented using this new technology. Okay. If you're happy with the way that the posts are already implemented, great. There's nothing to do. So it's up to you. Okay. Perfect. The coolants do also require, I'm going to hop ahead into this one. Go to here. It does require us to also modify your machine definition, which I'll show you. He is right here. And we specify which coolant document you want to use. Okay? Now, again, it still has to be hooked up in the post as well, so the best is to reach out to us. The final improvement, since we're on to that next section now, come on down here. The final improvement is on the machine definitions themselves. We've now made it possible to define in the machine definition a parking position for tailstocks and steadies. So if you've ever made a machine definition, then this will seem familiar to you. If not, and you have us do it for you, then again, reach out to us and we'll take care of it for you. So you have something called a tool change position. This is what tells the software where to return something to. So I want to set where my steady returns to. I can hit plus, I can call this arc 1, and I can leave this just in that position, right? And then I can say this is my current and starting, that's how I want to default. And then I'm going to say arc 2, for example, maybe it takes 3 seconds. And my W, let's say, oops, we want this to be 110. Is there? Okay. That is the park position underneath there, C of 0. So now we have 2 positions that are easily accessible to use within a link movement. Same thing for then a title stock. So this should make working with these types of components significantly simpler. Okay. In years past, in order to park these, you went to a virtual jog. So now you don't have to use the virtual jog. You can do it directly in the link movement of the operation itself. Okay. Cool. All right. I believe that's it for this webinar. We covered link movements, tools, and machines and components. I'm going to go back to my little presentation here, make it official. Let's see if there's any questions that are open that need to be answered. Perusing through here. If anyone else has any questions, feel free to type them in right now. But it looks like Joe was on the ball and got everything done. So I don't see any other questions coming in. So again, thanks for your time today, and we will see you at the next webinar. It starts at 1 p.m. where we will continue going over additional improvements for TopSolid Cam. If it's your lunchtime, enjoy your lunch and talk to you soon.